So let's talk about SparkSQL, very important component of Spark. In fact, you could say it's kind of taken over. Pretty much all of Spark is moving toward data frames and data sets. So let's talk about what these things are. So the whole point of SparkSQL and its associated technologies is dealing with structured data. So up till now, we've been dealing with these RDDs that can contain pretty much anything. You can just stuff whatever you want into a row of an RDD. But with data frames and data sets, you can actually wrap structured data in Spark and Scala, and there are some advantages to doing that. It lets Spark represent things more compactly and more efficiently, and also lets it optimize better. So what is a data frame? Well, a data frame is basically an RDD of row objects. That's really all it is. And a row can in turn contain any number of columns of information that may be of whatever type you want. So it's starting to look a little bit more like a database, right? We have these rows of information with discrete columns of given types of data. So we're starting to move from sort of a blobby RDD to a more structured representation of our data. And the good thing is that you can actually treat this like a SQL database. Once you have a data frame, you can actually run SQL queries on it using actual SQL commands. It has an actual schema, and this lets Spark represent it more efficiently. And it also has the advantage of being able to write out to database formats and also import data directly from database formats. So if you can connect to a JSON database or a JDBC database of some sort, you can interoperate very easily with Spark and SparkSQL. Now, we also talk about data sets. So what's the difference between a data set and a data frame? Well, a data frame is really a data set. It's a data set of row objects. A data set, more generally, is a set of structured data. Not necessarily a row, but it could be a specific type in Scala. So for example, let's say I have a case class in Scala of a person that might consist of a string name and an integer age and so on and so forth. I can have a data set of person objects. And the advantage of that is that Scala and Spark will know upfront at compile time what's in that data set. So if there's any errors that pop up while trying to optimize that, you'll hear about that when you're compiling as opposed to later on when you're running it. And that can be important because by the time you're actually running this code, you might be on a cluster where time is money. So catching these errors a little bit earlier is a good thing. It also lets it do a little bit better optimization as well. And you can also convert RDDs to data sets very simply. There's a toDs function. And if you have a known type inside your RDD, you can use that to convert it into a nice structured data set for you. So data sets really are the new hotness. I can't stress this enough. You know, we've kind of learned a lot about using RDDs up to this point in the course, and that's a very important fundamental thing to have under your belt with Spark. But the trend is more and more to use data sets instead of RDDs wherever possible. Now, it doesn't always make sense. You know, you don't always have structured data, and not everything can be thought of in terms of SQL or as of a database. So if you're just doing straightforward transformations of data, maybe data sets aren't appropriate. But for a lot of data analysis tasks, data sets are going to be the API of choice going forward. They're really taking over. And it also is important for interoperability because it is also seeping its way into other aspects of Spark. MLlib is moving toward a data frame-based API. Spark Streaming is moving towards something called structured streaming that also relies on data sets. So as we look forward, data sets are going to become more and more important to Spark over time. How does it work? Well, one important difference is that you're going to create a Spark session object instead of a Spark context object when you're dealing with SparkSQL and data frames and data sets. And this Spark session wraps a Spark context and also a SQL context. So you can actually get at those underlying components, but it's sort of a one-stop shop for any processing you need to do. You can get back a Spark session and actually run SQL commands on it directly. And remember to stop that session when you're done. It's just like opening a database connection from a programming standpoint. And there's some cool stuff you can do with data frames. So you can not only just run SQL queries on them directly, but you can also do SQL-like things programmatically. So for example, you can call .show to display the top 20 results in a data frame just for debugging purposes. .select, just like a select statement in SQL, pull out some specific column that you want to look at. Filter, you can actually do syntax like this, which is kind of weird, but cool. You can say, for example, my result data frame, extract some specific column and test whether that's greater than some number. So you can actually put in little expressions here and it will just work. You can do a group by just like you could in SQL. You can do things like mean and other, average and arithmetic expressions as well. So it's a very powerful group of commands and functions that have been added on top of what you can normally do. And you can also express this just using plain old SQL commands as well if you're more comfortable with that. You can also get back a RDD from a data frame. So if you want to do the sort of old school techniques like mapping and things like that, or a flat map, you can extract the RDD out of a data frame and do that as well. Another cool thing is once you are using SparkSQL, you can actually open up a SQL connection and treat Spark just like any other database. So if you actually take a data frame and cache the results, you can just let it sit there, and you can actually open up a server that will let you connect to it. And if you're actually using the Databricks Community Edition, you can actually do that within a notebook as well. Pretty cool stuff. User-defined functions, another cool aspect of SparkSQL. You can actually define your own functions and put them in your own SQL context. So, for example, let's say we want to define a function that will square something. We can just say val square equals this little inline function, x gets mapped to x times x. And we can do something like this to actually add a new column to our data frame. Let's say we have one column in there called value. This code will add a new column called square using our user-defined function to take the value and square it. And you can also do the same thing in a SQL query. So once you define a user-defined function, you can actually use that within your SQL going forward. So it's also very extensible. So it's all very hand-wavy up to this point. It's going to make a lot more sense when we actually dive in and do it. So let's go ahead and dive into a few examples. Like I said, data frames and data sets are increasingly important to Spark, so I want to spend a little bit of extra time on this. What we're going to do is go back to our fake social network data, and we're going to do a couple of things with it. First, we're going to do some queries on that data using straight-up SQL commands, so treat it just like it's a database and see how that works. Then we're going to go back and actually use data sets without SQL and just query those using commands on the data set itself and see how that works. A little bit more efficient. And finally, as an example of how you can actually use data sets as an alternative to RDDs, we'll go back to our most popular movies example and rewrite it using data sets instead of RDDs and see how much simpler that is. And in theory, it should be a lot faster as well. So let's get our hands dirty and dive in.